Grain growers face plenty of challenges. Here's another one that I prepared earlier. Cereal rust diseases are a major problem for the grain growers of the world, and since it entered Australia in 1979, stripe rust has been a significant problem here too. Fortunately for Australian farmers, Australian researchers lead the world in both understanding and controlling rust. It's a microscopic fungi infection capable of packing a big punch. Stripe rust can defoliate plants, suck up nutrients and slash grain yields. It's estimated that the latest epidemic is costing Australian wheat growers between $40 and $90 million a year to control, and left uncontrolled, it could cost the Australian industry $1 billion a year in lost productivity. Mike O'Hare grows 700 hectares of wheat as well as barley, canola and livestock on his property at Beckham in southern New South Wales, a prime habitat of stripe rust. But spores won't find much of a welcome here. He chooses resistant varieties.
Well, we see that as the major part of our strategy for stripe rust control, because it ensures that we don't have to implement serious fungicide programs, and that's really the place to start with and the most important.
Mike avoids routine fungicide spraying because it has to be applied before he knows how the season's going to turn out. Rust likes damp conditions, and in dry years like 2009, it's hard to justify the extra cost.
Anybody who adopted a fungicide strategy to control stripe rust this year would have planned to put those applications on, would have had them on, and then as the season's gone downhill, they've spent the money. So whereas a resistant variety approach, at least you haven't had that upfront cost, and the crop might be going downhill as well, but at least you haven't spent that extra money on it.
Mike's crops have remained rust-free in recent seasons despite outbreaks in the local area. But in 2005 he lost 20% of his yield on one of his wheat varieties because it was susceptible to the new strain. It only served to reinforce his commitment.
It just showed the benefit of having a variety that isn't going to take the rust and, suffer losses before you know about it. And other crops we had that year of other varieties which still had good resistance, they were fine.
They also don't provide the so-called green bridge between seasons. If your variety's not resistant, it's important to destroy any plants that might act as a host and infect your next crop.
Well, the rust pathogens survive only on living plants, so they must have a living host on which to survive. So getting from one growing cycle to the next is one of the biggest challenges these pathogens face in Australia, and they'll do that on self-sown wheat. And if the wheat has come from a susceptible variety, then it will actually assist in allowing the rust to survive from one season to the next.
Professor Park heads the Cereal Rust Laboratory team here at Sydney University, which hosts the Australian Cereal Rust Control Program. It's a collaboration that links scientists from the likes of CSIRO and Adelaide Uni with CIMMYT in Mexico, the world's premier cereal research institute and a vast storehouse of plant genetic material, the building blocks of plant breeding.
Not only are we doing the basic research and finding the new sources of resistance, but we work with the breeding companies to help them get that resistance into their material. So this year we actually have about 100,000 wheat breeders' lines that we're testing in a nursery very similar to the one we're standing in here. And then that goes through a process of recurrent selection until we end up with varieties that are rust resistant that are then put in farmers' fields.
Samples of every strain of stripe rust known in Australia are kept in cold storage here at Sydney Uni. 30 years of history frozen in time. Researchers use these samples to track the disease at a molecular level and to identify which plant genes will produce resistance.
It's in the industry's benefit, or interest as a whole, for farmers to grow primarily resistant varieties. This reduces the size of the rust populations, it reduces the inoculum load threatening crops, and it also reduces the number of mutants that can develop into new races and threaten to overcome resistances in varieties.
It's a numbers game. The fewer the spores, the less the opportunity it has to spread. And if there's one thing that this microbe is good at, it's getting about.
It's very well adapted to spreading over large distances on the wind. It can travel up to hundreds and even thousands of kilometres, and also by adhering to clothing. The spores are adapted to actually sticking and can be transmitted quite easily that way.
And that's exactly what's happened in the recent epidemic. A totally new strain arrived in WA in 2002, probably brought in from the US on someone's clothing. It was scientists here who first identified it and tracked its spread to the eastern Australian wheat belt. Even they were surprised by its virulence.
First arrived and I looked at it and examined it as I am here in this greenhouse. I thought it's certainly different, but I didn't think it was particularly nasty in what particular genes it was able to affect. I couldn't have been further from the truth. It was very aggressive, remains aggressive, has developed a number of mutations which have led to new pathotypes.
That's why the Cereal Rust Control Program's work of constant monitoring of rust samples from the field is so important. Armed with up-to-date information, scientists test all samples, then advise growers how new rust strains will affect their crop varieties and if fungicides are necessary. If you notice stripe rust developing abnormally, that is against expectations, it's possible that what you've got is a new strain, and it's really important then that you report it straight away. It's also important that the first outbreaks in your district are also reported as quickly as possible. This rigorous independent testing means that growers can have confidence in the results. It's what Mike O'Hare relies on when he's choosing new varieties. He has GRDC trials on his property, but uses the genetic information supplied by the Cereal Rust Laboratory to make his final decision.
We won't select the variety until we know it performs well in our environment for starters, and then we use this information to make sure that that variety is carrying reasonable resistance to the rust that we're worried about.
To be safe, he'll generally use a fungicide seed treatment in the first year, then sow a small batch so he can seed increase himself and get used to the new variety. Then if he's happy, he'll introduce it on a wider scale. Then he starts the process all over again.
We always strive to have the most resistant varieties we can. And of course, with changing stripe rust status of some of those varieties lately, that's been pretty hard to keep up with, but we're doing our best to keep in front of it.
The one thing that growers can be sure of, though, is that it's not a race they have to run alone. Investment of grower levies through GRDC means they have the world's best expertise and research behind them.